Okay, good morning, Fine Science 2. Okay, good morning. I started to record the lesson. I need to record because I want to get the attendance. The attendance only will be recorded when I record the video. Because every lesson I record, okay? I record the video to get the attendance, okay? Right. This is the fifth week already. Fifth week, we have lesson online, okay? This week and the next week will be the last week already. After that, you go for holiday for 1 month. 1 month of holiday. Okay. So remember now, this week the class still on as usual online. And also next week the class still on as usual. Okay. So after next week, then you can have your holiday for about 1 month now. Then 20th January, you'll come back to school. Okay. Everyone will go back to school. Okay, now I start sharing the paper with you. Okay, come. I want to start with this paper, okay? This set of paper. Can you all see the paper or not? Can you all see? Can see or not, everyone? Chan Yijing can see or not?
Can, sir.
Can, you all have this paper or not? Okay. Let's look at this question. We go quickly. I want to go through the paper. Okay. This paper is let me take out a pen first. All right. To study the relation between the speed, okay, and the height of the trolley. As you see the diagram here, right? So you are manipulating the height, and then you are getting how fast the trolley run down, get the speed. So it's a relationship between, very simple, between the height and the speed, correct not? So by manipulating the height, okay, you see how fast the trolley go down, okay? So the result is already here. Now you see, can you get the result? Okay, get the result here, or get the result here. First one, how many cm? Use a ruler to measure on the paper. Use ruler measure. Use a ruler measure on the paper. You cannot measure on the screen here now. Measure on your paper. When the height is 20, 30, 40, okay? So you get the height, you measure here, put it here, here, here. If you are using ruler, remember that. How many decimal you need to put? Kuhan, if you are measuring the height, the length of the ticker tape using a ruler, you need to give how many decimal? Fazli, how many decimal? If using ruler, Neil, how many decimal if you are using ruler? No one answer this question.
One.
1 decimal. Ruler can only give 1 decimal in centimeter, okay? If this one you don't have the paper now, okay, you go and print out the paper, you do yourself now, okay? Measure the length, put here. Measure the length, put here. Measure the length, put here. Then how to calculate the speed? Okay, the speed you calculate using the information given in the question. You see here. Use this formula to find the speed. Take S divided by 0.2. Take the length you measure just now, divide by 0.2. Understand? Divide by 0.2 to get the speed. Understand, everyone? So just follow the instruction from the question to find the speed. You take length divided by 0.2 time to get the speed. Okay? So for all this, so 1, 2, 3 here, 4 and 5 is here. Okay? All the value, you get it measured and calculate the speed. And now we answer this question. The one you do later, all this, okay? I just want to go through very fast. Okay, what is a manipulated variable in this question? What is a manipulated variable? What is a manipulated variable? Type the answer, please. H, yes, new, you are correct. Manipulated is a height, the H. Okay, the H, Alamak, very teruk lah. Okay, the manipulated is H. All right. Then what is responding variable? Type the answer. What is responding variable? Yes, velocity, the speed. Okay, responding variable is the speed. Okay, so manipulated is a H, responding is a V, the speed. The next one, fixed variable. What must be fixed? You see the diagram. Frequency. When Vanessa say frequency. How do you think when you look at this diagram, what must be fixed? What must be fixed? Frequency. Vanessa, you say frequency is frequency of what? You have to speak. You have to mention specifically lah. What is a frequency? Frequency of what? Frequency of the timer is a frequency of the power supply actually. Frequency of the power supply. Frequency of power supply. Okay. So remember that. Okay, come you have a look at the answer. Check the answer, please. The answer is here. Okay. Height manipulated variable. This one. Responding variable, the velocity. And the fixed variable is the mass of the trolley, the frequency of power supply, right? Both lah. Frequency of power supply. The mass of the trolley also can know. Mass of the trolley must be fixed lah. And the frequency of the power supply. All right. Okay, take down the answer, please. And you should get this answer. Okay, take down the answer. 5.5, 6.9. When you print out the paper, you measure, it may be varies lah, because when you print out the paper, the length can be different a little bit lah. That's okay lah. So remember that. The sign is here plus minus 0.1. Okay. This measurement, your one later on you print out, you see it might be different slightly. Understand? But then same thing goes to the velocity lah. When you calculate, you take this one divide by 0.2, you get this. This one divide by 0.2, you get this, and so on, so on. Okay? So that table, the whole thing, 5 marks. Okay? And after later on, you plot the graph, you should get a graph like that. Okay? The graph, it doesn't pass through the origin, I suppose lah. Okay? It's because I see the value here lah. Maybe it won't pass through the origin. I didn't plot the graph, okay? You try when you plot, maybe you get a graph like that. And based on this graph, what should be the relationship? The next one, they ask relationship. What relationship is based on the graph? What relationship? Can you type? You don't want to talk, you type the answer, please. What relationship based on the graph? What relationship is this? Okay, someone type the answer. Directly proportional lah. Kimberly said directly proportional. Kimberly and Neil, you see the graph, is it pass through origin or not? Is it pass through origin? Linearly, yes, correct. It doesn't pass through origin. But don't worry lah, Kimberly, it's okay. Come, let me explain your listen. If you plot a graph, you use a ruler to draw, you get a line like that. It doesn't pass through origin, so you use increases linearly. Okay, you say V increases linearly with H for your relationship. But I'm sure some of you, you will adjust your ruler so that the graph passes through the origin. When the graph passes through origin, so you can keep the answer directly proportional. Kimberly, understand? You adjust a ruler, so your straight line pass through origin, then you can say V is directly proportional to H. That's fine, don't worry. Okay, it's okay one. After all, your answer relationship, the examiner will check your graph. If your graph, I'm sure the graph is very close to the origin now, very close one when you plot. It doesn't pass through, you say increases linearly. When it passes through the origin, so you write the answer directly proportional, that's all. Don't worry about this. Yes, Kimberly, you are right. It depends on your graph. It depends on your graph. If the graph is very near, right, you adjust a ruler, it passes through the origin, so it becomes directly proportional. But some of them, they follow strictly, they want to go to the point, so it doesn't pass through origin, so become increases linearly. Okay, And the last part is, as usual, last part of the question is what? You should know already. Normally, last part they ask what? Last one they ask what? Last one, sure they will ask precaution. Correct not? What precaution you want to give here? This one I don't want to tell you already. Precaution is a must-ask question. Yes, Kimberly. Avoid parallax error. Kimberly, can you give the full question? If just write avoid parallax error, not enough, The complete sentence should be what? Must give the complete sentence, Cannot say avoid parallax error. I told you how many times already, Avoid parallax error too long, lama, so lazy. Kimberly, don't be lazy. Align eyes perpendicular to the measurement. Position the eye. Still not good enough. New, align eye perpendicular to the measurement. Also still not good enough. Hey, you better don't play. This one mark. You must get the 1 mark. So what should be the complete answer? Kimberly, now she wrote, position the eye perpendicularly to the skew of ruler. One more part. Kimberly, that a few more words you need to write. What is that? Brandon put there, eyes is positioned perpendicular to the skew of meter rule to avoid parallax error. Yes, Brandon, your one is complete. Okay, so the complete answer should be like Brandon answer. You can see that. You can see the answer inside the box. Okay, Kimberly is a little bit lazy to type. That's why she didn't type complete. Okay, so just see the answer. The complete one should be like that, I need position perpendicular to the skew of meter rule to avoid parallax error. This, you write like this, only you will get 1 mark. Okay, understand? Very strict one, precaution. So, okay, So I think this question we have done now. Okay, got it done. Okay. For those who didn't have the paper, you didn't print out, okay, later on you'll print out and then you can see the video. I will upload the video immediately. Later on you see the video to complete your works. Don't be lazy or no. Okay, next question. Now this question you are given a graph. You know why I want to focus on paper 3, okay? Because last few days I sit down quietly, I think, okay? Student must do, actually I want you all to focus on paper 3. Paper 3 can give you a lot of marks. Paper 3, not so difficult one. Because paper 3, the questions the format, it wouldn't run so much one. Every year, same one. Question 1, question 2, same one or like that. Okay, the format now. So you need to have more practice on paper 3 now. That's why this I started to give you all paper 3 now. And yesterday I give you another set of paper 3. So let's practice more on paper 3 now, Okay. Okay, now this question given. So this question is about student carry out experiment to investigate the relationship between the angle of incident and the angle of refraction, I and R. So the graph psi I, psi R has been plotted like this already, the graph. So this is the relation between the angle incident and the angle refractions. So the graph of psi I, psi R plotted like this, right? Okay, now the question, typical question. That's why I want you to practice more. I can use the word typical. Typical means I'm sure they will come out and ask like this one. Typical question. Relationship. What is a relationship? When you look at a graph, what relationship? Type the answer, please. When you look at a graph, what relationship? You see the graph like that. What relationship? Please type the answer. Someone, please. What relationship like this? Answer, please. Type your answer. What relationship? Okay, let's check. Kimberly, directly proportional. Yes, correct. It's directly proportional. Vanessa? Excuse me. Yes, it's directly, but you have to write in full sentence. You write psi R directly proportional to psi X, psi I. Okay. Even though the question say psi I, psi R, so you follow the graph now. Psi R directly proportional to psi I. Okay, that's a relationship. Next question. Determine the value of I when the psi R 0.6. Show on your graph. You see, you must draw the line. They ask you to find the value I when the psi R is 0.6. So you do like this lah. 0.6. So you draw a line. You draw a line like this. Wait. Follow here. You draw a line here. Psi R 0.6. Draw. Don't be lazy. You must draw the line. Okay. Then from here to here, then you see here the answer 0.9. But 0.9 is not the final answer yet, because this 0.9 is psi I. So you need to get the I, because the question asks I. So draw a line 0.6, see the value here 0.9. This 0.9 is psi I. So you find the I value. So let's check the answer. You should do like this, okay? Someone typed already. 64.16. Vanessa say, see the answer correct not, Vanessa? Yes, correct. You are right, Vanessa. Psi I, you get 0.9, correct not? And then use a calculator to find the angle. You know what to do, Psi I 0.9. So use your calculator to get this answer. So the I 64.16. Okay, So this one typical question, no? You must know, Okay, done already, this one. Next one, shear gradient. Typical question, they ask gradient, Calculate the gradient of the graph. Okay, find the gradient. Then he said same thing again. Show on your graph how you determine. You must show the triangle on your graph. Show the triangle. You must draw triangle on the graph like this one. Okay, now you have a look here. Okay, now it's here. Show this triangle. Big one. Okay. Draw the big triangle. Okay, get the value here. Our value here is 0.6. Unit must follow a new unit now. 0.6. Here is 0.9. Both also no unit. Okay, this is 0.9. Okay, so the gradient is 0.6 divided by 0.9. Okay, so remember now, the graph have to be shown now. You show this one 0.6 here, 0.9 here. If there's a unit, you write a unit. If there's a unit here, right? But so far for this question, there's no unit here, no unit here. Okay, so gradient 0.6 divided by 0.9. Let's check the answer. Okay, now you see, wait, I want to tell you all. You see the marking scheme, what statement they give. Draw a sufficient large triangle to calculate the gradient. Please remember, at least 6 cm times x cm. Hey, remember, no, I'm not playing with you when you see carefully now. The triangle must be at least 6 times 8. 6 cm times x cm. Hours, do we have enough? Let's see. 6. Here, there are more than 0.8 already. Here, more 0.6. Okay, nah? 0.6 here, more than 0.8. Okay, so this triangle is big enough. Okay, it's big enough to find the gradient. So the gradient answer, you get 0.6 divided by 0.9, you get 0.67. This answer. Understand? Why size 2? Understand? I think I'm talking alone here. Nobody bother me.
Understand, sir.
Good. Thank you very much. Okay. Yeah. Okay. Typical question again. Last one, they ask one more part calculation. Min Pai sir, Chan Ching. Thank you. In now only come in. Okay. Now last part of the question. You see what the question asks there. Show a little bit calculation. You see here. Here. The last one will be calculation one. For question number 2, I mean. The index of reflection given by n equal to 1 over gradient is given n equal to 1 over gradient. So you calculate now. N equal 1 over gradient. The gradient answer. Okay. So you put it here. So you find the answer now. Okay. So you check the answer given. This one, 2 marks. This is like bonus marks, 1 divided by gradient. So you get the answer. Okay. So the answer is 1.49. You see, 1 over gradient 0.67 you get here. Okay. So n equal to 1.49. Remember now, refractive index has no unit. This one no unit. And the last question, also calculation. They ask you to find relationship between the speed of light and the speed of light in the A given n equal to C over V. Do you remember this formula? Speed of light in the vacuum divided by speed of light in the medium V. That is on V. So you are asked to find the V. Okay? Speed of light in the vacuum given already. This answer is just substitute. And substitute the N, substitute the C to find the V. So very simple, right? You substitute the C, this value, substitute the N, you got from the, then you find the V. So the answer is ini macam. I see. Okay, substitute the N, substitute the speed of light in the vacuum, you get V. This answer is incomplete. What is incomplete here? Can you tell me why? This answer I say is incomplete. What is incomplete there? Type. Can you someone please type me? Tell me why the answer is incomplete. Why the answer is incomplete? Can anyone tell me why? Why not incomplete? No unit. Yes, Plankton, you are right. No unit. Then what is a unit then? You must have a unit here. What is a unit? What should be the unit here? What should be the unit? Okay, come, let's see who give the answer. Meter per second. Thank you, Brendan. Okay, check the answer inside the box, everyone. Meter per second. Unit should be meter per second. You must have the meter. Okay, the last one, you see, they ask precaution again. You see, it's very typical one, they ask precaution to improve the accuracy. You see how they give the precaution. You see the answer. I must be perpendicular to the readings of the protractor. Is it using protractor? Anchor, I think use protractor. to avoid parallax error. So please follow this format answer now. For your precaution, understand? I must be perpendicular to the reading of protractor. You must mention the instrument. And then for what? To avoid parallax error. Okay? So remember that now. So paper 3, you all must score, because the question is very typical one. Every year, same one. Same format one. Okay? Yeah? Okay, I think we have finished this already. Yeah. Okay, now we go into the next set of paper now. Okay, come on, I need to take a pictures. But you all never on your camera one, your mind, see your name also okay. Okay, The next question will be on this paper. How many of you, sorry, I didn't share the paper. Sorry, okay, I need to share it. How many of you have this paper printed out? Kimberly, do you have this paper printed out or not? Kimberly. Ada. Okay, good. Kuhan, do you have this paper printed out? Kuhan?
Yes, sir.
Good. Okay, good. Amalina, have this paper printed out or not? Amalina? Good. Adi? You print out the paper, Adi?
Yes, sir. Then.
Okay, come. I want to start with experiment question. Okay? Pick up your foolscap paper. Foolscap paper to answer question number 3. Okay. The experiment question. Okay, you all cannot run away one. Or you have to answer the experiment one. Okay? Come, look at this question. Come. Read the question, you all. This experiment is something to do with what? Okay, you all see here. Diagram 3.1, 3.2 show a boy throwing a ball of different masses. You can see here that this ball is very small, it's light. This ball is heavier. Now you can see the difference, right? Using the same amount of force. Okay, you can notice here now when the ball is small, lighter, right? It goes faster, right? It goes faster, right? This one is heavy, it goes slower. So very obvious already now. This experiment is related to what? What relationship like? What relationship? Acceleration. Relationship must have two variable one, cannot be one. So what are the two relationship here? What are the two variable here? One definitely is a speed or acceleration. One is speed because this one fast, this one go fast, this one go slow, right? Okay, come, what answer you give? 1 plus 1. What 1 plus 1? Neil, what are you talking about? Mass and acceleration. Yes, correct. It's between the mass and acceleration. Okay? Mass, acceleration. What about speed? Can we use a speed? Can or not? Between the mass and the speed, or between the mass and the acceleration, which one is? Mass acceleration or mass speed? Which one? Which one? MA. Vanessa said MA. What about MV? MV can or not? Can you do the experiment for MV? Vanessa said must be MA. That one new. What you talking about? That one meter. What is that? Okay, come listen here. Okay, another answer. Let me check first. Okay, actually now both can. You can do mass acceleration. You can do mass velocity or speed. Can both also can. Okay, both also can. Mass acceleration, mass and velocity. Okay, let's confirm with section C. The apparatus given. You see what apparatus they give you first. Using the apparatus such as trolley, you need a trolley lah. Slotted weight no. Ticker timer. Then for what? A trolley, a slotted weight, and a ticker timer. These three things must be used on. So how to do it? Trolley, slotted weight, and the ticker timer. Okay, I think like this. You can put the trolley on a runway or just on the floor. It's okay one. You can make it on the floor or can put it on the runway. Then you use a ticker timer to measure the speed. Then this slotted weight is for what? What is the function of the slotted weight? Slotted weight function is to increase the mass of the trolley, correct not? To increase the mass of the trolley. But one thing I want to tell you, this question, we are manipulating the mass. You are increasing the mass by adding the slotted weight, right? To make it heavier. Then how to make sure the force, you use a force to push the trolley every time must be the same, How to make sure it is the same? How to make sure you apply the same force every time to push the trolley? How you do it? You have to think about all this, Frictionless pulley. No, I'm asking. Okay, you see lah. Come, you see the diagram. It's like that. So you put the trolley here, ticker timer, right? Then here the slotted weight. Okay, the slotted weight, I think you add here lah. The slotted weight. You add the slotted weight here later on. Slotted weight you put here. You plus 16 to put here. The weight. How to ensure every time the trolley is being applied with the same force? Okay, is elastic cord. You must pull the elastic cord now to the fixed length every time you pull the elastic cord with the same length. When the length of the elastic cord you pull every time same length means the force is the same. Of course, before you start, you need to hold the trolley, hold it first. Hold the trolley, then you pull the elastic cord, you pull here. Pull the elastic cord to the fixed length. The length you pull the elastic cord must be constant, Use a hand to hold the trolley, then you pull the elastic cord to a constant length, then let go. You let go the trolley, so the trolley will go down. So by using the elastic cord, the length you pull every time same, right? You can ensure the force is constant. Wait, understand? Understand or not? Okay, first questions are definitely they ask inference. Okay, how to give inference, how to give hypothesis. Inference, what keyword? Can you type the inference, please? Okay, type the answer. What is the inference? Slanted plane. runway lah. Depends. Acceleration depends on the mass. Yes, correct. Acceleration depends on the mass, or the velocity or the speed depends on the mass. That's correct. Okay, another answer, please, for hypothesis. Can you type the hypothesis? The rest, everyone see, see inside the box. Acceleration depends on the mass, is okay. What about hypothesis? Type the answer, please. Someone please type. Share your answer. To see the answer, you must click the chat box lah, huh? One answer for hypothesis. Hypothesis answer is what? Hey, someone please type. The larger the mass. Melissa, can you continue? Okay. Fazli say acceleration increases as the mass increases. Fazli, are you sure, Lord? Acceleration increases as the mass increases. Fazli, think again your Vanessa, the larger the mass. Okay, Kimberly, the greater the mass, the greater the acceleration. Why? Think carefully. You see the initial diagram. When a ball is heavier, it goes slower, correct not? Vanessa, the smaller the acceleration, smaller decrease. Okay, can someone please give a complete answer? The greater the mass, the greater the acceleration. Why? New got no sound already. Can someone please give a correct answer, please? Kimberly, give a correct one. I know you know the answer already. Someone please give a correct answer. Give Liao, give your head, Kimberly. Where's your correct answer? Complete answer lah. You want here a bit, here a bit, here a bit like that. Give one complete answer lah. Up there. The greater the mass, the greater the acceleration. This is still wrong. Wait, what is the answer lah? I'm sitting here to wait until you give the correct one. Type again one complete answer, Kimberly now. The greater the mass, smaller the acceleration. This is the correct one. The greater the mass, some fellows still. Wait, I shall call, please lah. Right now, I only see the Kimberly one. Kimberly one is correct. The greater the mass, the smaller the acceleration. Follow Kimberly answer lah, please Asher, your one is not correct. Okay lah, twice already lah. Okay, thank you Kimberly. Jangan panas. Okay, I said it again Please follow Kimberly answer. Only the Kimberly answer is correct. The greater the mass, the smaller the acceleration. Yeah. I hope you all get my message everyone please okay come I show you the answer What the answer given? When the mass increases, acceleration decreases. Okay. Please don't follow this one. This inference is wrong. This wrong answer given. For inference, you must use the keyword depends. Depends on. Okay, hypothesis. This one can. When the mass increase, acceleration decrease. This one is correct. This one okay. This one wrong. Please don't follow. See the teacher give answer also like that one. No. Tak boleh harap Malaysia boleh. Okay, aim to investigate the relationship between the mass and acceleration. This one can. That one is aim to investigate the relationship between the mass and the acceleration. This one okay. The manipulated variable, the mass, you manipulate the mass. Responding variable, acceleration, this one okay. Constant variable is a force. The force you apply must stay constant now, remember now. So this one mark here, 1 mark here, 1 mark here. Okay. Manipulated mass responding the acceleration, and the constant variable is a force, but you must know how to make the force constant. You pull the elastic cord. The length you pull the elastic cord must be constant. Okay. Yeah, got the answer already. Okay, next one, list of apparatus and material. One shot, see everything. AC power supply, ticker tape, ticker timer, ruler, elastic cord. Okay, pulley. Why need a pulley? Where's a pulley? Pulley no need. This one please cancel. This one no need. No need pulley. This one cancel. Trolley, connecting wire, slotted weight, wooden block. You need a wooden block here. Okay. Yeah. Take some time to take out the answer. AC power supply, ticker tape, ticker timer, ruler, elastic cord, trolley, connecting wire, slotted weight, wooden block, and the diagram. Diagram you must learn how to draw, The ticker timer is on top here, ticker tape is behind, ticker tape, this is a connecting wire, power supply, this is the trolley. Slotted weight you put on top here. Okay, use a plasticine to stick the slotted weight on top to make the trolley heavier. Slotted weight is here now. Wait, please label. This is slotted weight. This one is friction compensated runway. Compensated means you put a certain slumping, right? So it will move down automatically, like no more friction. Okay. The trolley can move down freely, like no more friction, so we call it friction compensated runway. Okay. But you cannot let it go down automatically like that. No, you have to use elastic cord to pull, because you need to fix the force. The force you need to fix it. That's why you need to use an elastic cord pull to a certain length. Every time the length of the elastic cord must be the same. Okay. Got it? Okay. Procedure. Procedure. First, determine the mass of trolley using weighing scale. Determine the mass of trolley first. A wooden block 0.2 gram placed on the trolley. Place on the trolley. For what? No? Use a wooden block. 0.2 is placed on the trolley. Switch on the power supply. Pull the trolley by fix. This is wrong. Very thorough this answer. Switch on the power supply. Pull the trolley by a fix. You say here, fix length. Elastic cord pull to a constant length. This one is correct. Okay. Elastic cord pull to the constant length. Okay. Actually here, first one, second one, you don't write. It's okay. One, you just write. The apparatus and the material are set up as shown in the diagram. Okay. And then you can say A wooden block, not wooden block now, slotted weight, okay, slotted weight of 0.2 kilogram placed on the trolley. A slotted weight, that's why you're using the slotted weight, right? Switch on the power supply, pull the trolley by, pull to a constant length, and then based on the ticker tape, obtain acceleration of trolley calculated by using this formula, okay? Find the acceleration using this formula lah. Just write the formula of final velocity minus initial velocity divided by time, okay? So first, second, third. This one is more important. Not wooden block, slotted weight, okay? This one put slotted weight, okay? Slotted weight. Put the slotted weight 0.2 kilo on top, okay? Okay, last one will be the repetition. Okay? Repeat the experiment with another 4 different values. Nonsense. Repeat the experiment by increasing the mass to 0.4, 0.6, okay, like that. This one. Okay. Switch on power supply. Based on the ticker tape, acceleration is calculated using this formula. Then you say, last, repeat the experiment by increasing the mass to 0.4, 0.6, 0.8, 1.0 kilogram. That will be fine, okay? Yeah. Okay, after this is your tabulation of data. So your table should look like this lah. Mass, acceleration, okay? You have to write the value 0.2, 0.4. Don't put M1, M2. So please put here 0.2. First one, you started with 0.2. The second one is 0.4. Write it 0.4. Because this one manipulated. Manipulated means you already know one. So you can write 0.2, 0.4, and so on. Okay. 0.6. 0.8. And the last one was 1.0. Okay, please write the answer. Okay, this one you have to write now. Your paper should be like this: 0.2, 0.4, 0.6, 0.8, 1.0. And here, acceleration, you need to write. But make sure you have the unit correct now, meter per second square. Okay? Or cm per second square also okay. Huh? And last is a graph lah. Graph, you should plot what graph against what graph. What against what? Can you type the answer? What graph are you supposed to plot? Type the answer. The way you analyze data, okay, you must plot what graph. When you type the graph, type what against what. What graph are you supposed to type? Can you someone please type the answer? What graph are you supposed to type? Okay, come. Mass against A. No, not correct. The answer not correct. Both of you give the answer not correct, you know. It should be what against what. What is the rules of plotting a graph? You must plot what against what. You must be responding against manipulated. Okay, come, let's another one. Vanessa, mass against acceleration. Not correct. A against mass. Yes, Adi, you are correct. Shakira, you are correct. Hey, please see Adi and Shakira answer. These two are correct. We must plot acceleration against mass. Acceleration against mass, don't simply plot, no. I simply plot means that you throw away your 1 mark. It must be responding variable. In this case, our responding is an acceleration. And the manipulated is a mass, so it should be acceleration against a mass. Okay, Adi, Shakira, thank you. So you see, it must be like that, Here must be acceleration. Here must be manipulating. Okay, this one is RV, responding variable, RV. Here must be MV, manipulated variable. MV here, RV here. Hey, don't make mistake. This is the last marks. Okay. Okay, last question. We have a few more minutes. We just have a look of the question. See what we can do. This one. Just have a look at the question. Okay. On this diagram show a water wave propagated from the sea to the shore. So the water here is very deep. You can see, right? Water is deep. Then the water propagated to the shore. Here the water becomes shallow, right? So what you can see here now, over here the lambda is big. You see the lambda is very big. When it reaches the shore, the lambda becomes small. You see the lambda also becomes small. So you can see here, this lambda big, this lambda small. So what relationship is that? Wavelength and the depth. Yes, Neil, you are correct. Wavelength and the depth. So this question is between the wavelength lambda and the depth, okay, d. Okay, is a relation between the lambda and the depth. Okay, relationship. Lambda and the depth is here. So quite easy lah, this experiment. Okay, can someone please type the inference and the hypothesis? Okay, type the answer, please. Inference is what? Okay, inference here. Vanessa say the wavelength depends on the depth. Yes, very good. Vanessa, you are correct. Take the Vanessa answer now. Wavelength depends on the depth. Okay. Hypothesis, can someone please give the answer for hypothesis? The larger the depth, the larger the wavelength. Yes, correct. Okay. The larger the depth, the larger the wavelength. Can you all see the answer one or not? Adia, can you all see the answer inside the box one or not? Can see or not? Inside the chat box, you all can see one, isn't it?
Yes, sir.
You all can see, see the answer lah, okay. The wavelength depends on the depth. The larger the depth, the larger the wavelength, okay. That's okay. So this is correct already, See the answer, please, Okay, next one is we still have 2 minutes, never mind, With the use of apparatus such as Reaper tank, that's why I told you, you must draw the Reaper tank, you know. Okay, Reaper tank and other suitable apparatus. Describe the experiment framework. Okay, now your answer this one first. Aim, what is the aim? Can someone write the answer? Aim. How to write aim? Aim is what? To investigate the relationship between the depth and wavelength. Yes, correct, Vanessa. Thank you. Please see the answer now, please. To investigate the relationship between the depth and the wavelength. Okay, variable. You have MV. You have RV. Okay, write the answer before I stop. MV is what? RV is what? Constant variable is what? CV is what? Okay, please add it up. What is the answer? MV is what? RV is what? CV is what? This is the last line. I want you to keep the answer. MV is a depth. Yes, Vanessa. RV is a wavelength. Yes, correct. Okay, CV, constant variable. Frequency. Yes, correct. Frequency. Frequency of the motor of the frequency of the motor. Okay, or we say the frequency of the water wave must be the same frequency. Okay. Any other alternate answer for constant variable besides frequency? Okay, for sure, MV must be depth, no other alternative. RV must be the wavelength. Or what about a constant variable? Any other answer can give? Besides frequency, frequency of the electrical motor, the motor vibrate one. Types of water. Types of water is it important? No, types of water not important. Types of water not important. Density, density no. It's nothing to do with the water. Nothing to do with the water, you know. One more thing is very important one. When you set up the Reaper tank, when you pour water, there's something important, you know. What must be fixed? Okay, it should be like this lah. The speed, no. It should be the depth of the water before you start the experiment. You pour water on this Reaper tank, right? Before you start experiment, the depth of water must be uniform one, you know. Because the depth will affect the speed and affect the lambda. The overall depth, before you start, before you put the plastic inside the water to make it shallower, right? How to make it shallow, getting shallow, right? You put plastic inside the water to make it shallower. Isn't it one piece plastic, 2 pieces, 3 pieces you put inside? Okay, before you start, you must make sure the water depth is uniform. Uniform. You want to make sure the water speed is uniform before you start the experiment. After you started, of course, it's different now because you put the glass under the water to make it shallower. 1 piece, 2 pieces to make it more and more shallow, correct not? Yeah. Okay, the rest of the questions, I want you all to try to do it first. You print out the paper, try to answer the question. Okay? Yeah. All right, I see you again on Wednesday. Okay, 5 Science 2. I see you again on Wednesday. Okay, so please send in your attendance, everyone. For those who haven't send your attendance. Send your attendance. Okay, I see you on Wednesday again. Wednesday. Okay, thank you. 5 Science 2. Bye-bye. Okay,
Thanks,
bye-bye,
sir.
everyone.
Bye, sir.
Yes, bye-bye.
Thank you, sir.
Okay, bye-bye. Bye-bye, everyone.